Learning objectives. At the end of this topic, you will be able to define solution in matter, discuss about separating the components of a mixture, explain the physical and chemical changes in mixture, know about the state change of matter, explain the types of pure substances. Introduction. So let me begin my chapter on Is the matter around us pure? Sheila and her mother went to a nearby grocery shop to make monthly purchase. How do we judge whether milk, ghee, butter, salt, spices, mineral water or juice that we buy from the market are pure?
By the color of the substance, we can find whether it's pure or impure.
Right. Have you ever noticed the word pure written on the packs of these consumables?
Yes, I have seen in some packets.
For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is the actual mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of a single type of particle. In other words, a substance is a pure single form of matter. Let me tell you more about it in this chapter. What is a mixture? Mixtures are constituted by more than one kind of pure form of matter known as a substance. A substance cannot be separated into other kinds of matter by any physical process. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a substance and cannot be separated by a physical process into its chemical constituents. Similarly, sugar is a substance because it contains only one kind of pure matter and its composition is the same throughout. Types of mixtures. Depending on the nature of the components that form a mixture, we can have different types of mixtures. Let's perform an activity. Take 4 beakers and name them as A, B, C, and D. Beaker A contains 50 ml of water and 1 spatula full of copper sulfate powder. Beaker B contains 50 ml of water and 2 spatulas full of copper sulfate powder in a beaker. Beakers C and D contain different amounts of copper sulfate and potassium permanganate or common salt, sodium chloride, and mix the given components to form a mixture. Let's note down the observations. Beakers A and D have obtained a mixture which has a uniform composition throughout. Such mixtures are called homogeneous mixtures or solutions. Both the groups have obtained copper sulfate solution, but the intensity of color of the solutions is different. This shows that a homogeneous mixture can have a variable composition. Beakers C and D have obtained mixtures which contain physically distinct parts and have non-uniform compositions. Such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron filings, salt and sulfur, oil and water are examples of heterogeneous mixtures. Let's perform another activity. Take a few crystals of copper sulfate, spatula of copper sulfate, chalk powder, and a few drops of ink. Pass a beam of torchlight through it and leave the mixture undisturbed. We can observe that copper sulfate is a solution. Chalk powder has got a suspension and drops of ink has got colloidal solution. What is a solution? A solution is a homogeneous mixture of 2 or more substances. Lemonade, soda water, etc. are all examples of solutions. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in a lesser quantity, is called the solute. Let's discuss the properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nm, so they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So, the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed, that is, a solution is stable. Concentration of a solution. In a solution, the relative proportion of the solute and the solvent can be varied. Depending upon the amount of solute present in a solution, it can be called a dilute, concentrated, or a saturated solution. Dilute and concentrated are comparative terms. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it's called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. The concentration of a solution is the amount of solute present in a given amount, mass or volume of the solution, or the amount of solute dissolved in a given mass or volume of a solvent. Concentration of solution is equal to amount of solute by amount of solution. We shall discuss two ways of expressing the concentration of a solution. 1. Mass by mass percentage of a solution is equal to mass of solute by mass of solution into 100. 2. Mass by volume percentage of a solution is equal to mass of solute by volume of solution into 100. What is a suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Let's discuss the properties of suspension. Suspension in a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed, that is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. What's a colloidal solution? The particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of the colloidal particles, we cannot see them with naked eyes. But these particles can easily scatter a beam of visible light. The scattering of beam of light is called the Tyndall effect. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in the air. Let's discuss the properties of colloidal solution. A colloid is a heterogeneous mixture. The size of particles of a colloid are too small to be individually seen by naked eyes. They cannot be separated from the mixture by the process of filtration. But a special technique of separation known as centrifugation. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and the dispersed phase. Separating the components of a mixture. How can we obtain colored component dye from blue or black ink? Heterogeneous mixtures can be separated into their respective constituents by simple physical methods. Sometimes, special techniques have to be used for the separation of the components of a mixture. Let's discuss about each one of them. Let's conduct an activity to understand how to obtain colored component, dye, from blue or black ink. Fill half a beaker with water. Put a watch glass on the mouth of the beaker. Put a few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see that evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. Observe carefully and record your observations. We find that ink is a mixture of a dye in water. Thus, we can separate the volatile component, solvent, from its non-volatile solute by the method of evaporation. Let's conduct an activity to illustrate how to separate cream from milk. Take some full cream milk in a test tube. Centrifuge it by using a centrifuging machine for 2 minutes. Sometimes, the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Let's discuss its applications. This principle is used in diagnostic laboratories for blood and urine tests. Used in dairies and home to separate butter from milk. Used in washing machines to squeeze out water from wet clothes. Let's conduct an activity to illustrate how we can separate mixture of two immiscible liquids. Let's try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Close the stopcock of the separating funnel as the oil reaches the stopcock. Let's discuss their applications. To separate mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. We have learned that ammonium chloride changes directly from solid to gaseous state on heating. So to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity, the sublimation process is used. Some examples of solids with sublime are ammonium chloride, camphor, naphthalene, and anthracene. Let us understand. Is the dye in black ink a single color with the help of an activity? Take a thin strip of filter paper. Draw a line on it using a pencil, approximately 3 cm above the lower edge. Put a small drop of ink at the center of the line. Let it dry. Lower the filter paper into a jar or glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level, and leave it undisturbed. Watch it carefully as the water rises up on the filter paper. Record your observations. Let's note down the observations. The ink that we use has water as the solvent and the dye is soluble in it. As the water rises in the filter paper, it takes along with it the dye particles. Usually, a dye is a mixture of 2 or more colors. The colored component that is more soluble in water rises faster, and in this way, the colors get separated. The process of separation of components of a mixture is known as chromatography. Chroma, in Greek, means color. This technique was first used for separation of colors, so this name was given. Chromatography is a technique used for separation of these solutes that dissolve in the same solvent. Their applications include to separate colors in a dye, pigments from natural colors, and drugs from blood. How can we separate a mixture of 2 miscible liquids? Let us try to separate acetone and water from the mixture. Take the mixture in a distillation flask. Fit it with a thermometer. Heat the mixture slowly, keeping a close watch at the thermometer. The acetone vaporizes, condenses in the condenser, and can be collected from the condenser outlet. Water is left behind in the distillation flask. This method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. To separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K, fractional distillation process is used. For example, for the separation of different gases from air, different fractions from petroleum products, etc. The apparatus is similar to that for simple distillation, except that a fractionating column is fitted in between the distillation flask and the condenser. Let's view a simple fractionating column. It is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly. How can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fractional distillation. Let's view the flow diagram which shows the steps of the process. If we want oxygen gas from the air, we have to separate out all the other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get liquid air. This liquid air is allowed to warm up slowly in a fractional distillation column, where the gases get separated at different heights depending upon their boiling points. How can we obtain pure copper sulfate from an impure sample? Let's perform an activity to illustrate to obtain pure copper sulfate from an impure sample. Take some approximately 5 grams of impure sample of copper sulfate in a china dish. Dissolve it in a minimum amount of water. Filter the impurities out. Evaporate water from copper sulfate solution so as to get a saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool down slowly for a day. You will obtain the crystals of copper sulfate in the china dish. This process is called crystallization. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. In cities, drinking water is supplied from waterworks. Let's discuss flow diagram of a typical waterworks. To understand the difference between a pure substance and a mixture, let's understand the difference between a physical and chemical change. The properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc., are the physical properties. The interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in the chemical composition. Chemical change brings change in the chemical properties of matter, and we get new substances. A chemical change is also called a chemical reaction. On the basis of their chemical composition, substances can be classified either as elements or compounds. Robert Boyle was the first scientist to use the term element in 1661. Antoine Laurent Lavoisier, 1743–94, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be normally divided into metals, nonmetals, and metalloids. Let's discuss the properties of metals. They have a luster, shine. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. They are sonorous, make a ringing sound when hit. Let's discuss the properties of nonmetals. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and nonmetals. They are called metalloids. Examples are boron, silicon, germanium, etc. Compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. We can summarize the physical and chemical nature of matter in the graphical organizer as shown. Summary. Let's summarize the topic. Mixtures are constituted by more than one kind of pure form of matter known as a substance. Solubility is the term to denote the amount of solute present in the saturated solution at this temperature. Colloidal particles are uniformly spread throughout the solution. We can separate the volatile component, solvent, from its non-volatile solute by the method of evaporation.